All right, we're going to cover AES. Now, you guys obviously looked it over already, so we can cover this fairly quickly. Okay. I didn't make these slides, so if you got any problems, contact Raymond. They have them corrected. But okay. Now, Raymond actually made them for me as a project and did a great job, and they're decent. There's a couple things that are not quite explained perfectly, but I have additional items to go with this. Now this PowerPoint should be up there. It's animated, so if you walk through this on your own in your own time, make sure you do the slideshow. That way you can see the animation, see where the numbers go. So if you don't use the animation, it just shows you the ending position of it. Okay, let's talk about AES. Advanced Encryption Standard. Made from the Richendale algorithm. Okay. FIPS 197, and I like what it says here. A system that can break DES in 1 second. Y'all know what DES is now, hopefully. Everybody remember DES? Okay. A system that could break that in 1 second would take 149 trillion years to keep the color changes. I swear we say this every week. Okay, so it would take 149 trillion years to break AES with this smallest encryption key. So, much, much nicer system. Works good in hardware, works good in software, works good pretty much for everything. Works for everything you think of. I don't know anything that it wouldn't work with. So, very nice because it is adjustable. Kind of like DES, we were stuck with 64-bit blocks and 16 rounds. This we can actually change, make it work differently. All right.
Was the most secure.
What?
Triple DES was the most secure.
Yeah, well. Okay, details. It actually is what's called a Feistel structure. It says some of the bits in intermediate stages are strictly transposed, and we're going to see how that works. We're going to walk through it, okay? It uses transformation layers, and I have an executable little flash video somewhere. I'll try to put it up if I find it. It's very confusing, but it does kind of give you another view of it, which I'll find and put it up there, okay? It uses something called SubBytes. That uses shift rows and mix columns, then finally adds the round key. We're going to see how each one of these steps work. And as we're going through it, actually let me show you your homework real quick right now before we get into the algorithm itself. Okay, up in D2L, you'll see a practice sheet. Maybe. Yes. Okay, in the past, this was your homework. Okay? But it was only partially filled in. You had to go through all this stuff, okay? So what we've done is we actually give you the entire thing filled out 100%, so that what I ask you to do is before you ask me questions on your homework, look at this to make sure you're doing it the correct way, okay? In the past, like in this section right here, this matrix multiplication area, we would give you everything but this right-hand column. So basically the 83, 42, 26, and E6 were not filled in, but everything else was. But it would be funny. Students would come and ask all kinds of questions about the last column, but I said, well, did you walk through the first 3 columns? No one ever did. Yeah, they just never did. So before you ask questions on your homework, at least walk through this and figure out how we got the answers, because I'm giving you the entire thing all filled in, okay? All the way down to the end. Okay, so that's up there. What your homework is has been modified for this year. No, you can't. What it is this time is you're going to use your own name. So unless 2 of you are called Marlene Moore, sorry, you're out of luck. So you basically take your name and you repeat it until you get 16 characters. Hence, Kenneth Dewey, K-E-N-N-T, get to 16 characters. Then you do the entire thing based on, instead of computerized 1357, you do it with your name. Okay? Now, I can check it. I'm totally fine with checking your work. So do some of it and send it to me. Hey, I'm on the right track. So I have no problem checking it for you. Everybody understand that? Okay. Don't do the whole thing and then ask me. Don't wait until the day before it's done. If it's due on a Sunday, you're probably not going to get an answer that weekend. So start working on it, but go through it for your name. And so everybody's going to be graded separately, and I have an answer key that automatically calculated, so I know what yours should be. Okay? So that's what your homework is. I think I give you 2 weeks for it. Is that correct? And there's also a very, very, very important sheet up here called matrix instructions. We're going to talk more about the matrix multiplication in a minute, but this is on there as well. This is the one area that the slides aren't totally clear on exactly what does what. So I'll explain this again here in a minute. Okay. All right, so before we get into that, let's move on with the presentation. Okay. All right, AES resistance to all known attacks. It's speed. It's basically open source. It's based on sound mathematics, not secrecy. Okay. It's a strong math foundation. The number of rounds, variable block size, everything is all variable. So it makes it very nice. Okay. You guys should have seen this before. You did it with Des. Remember we did that? Okay. So if we were to take D, becomes 44. Do you all see how that works? So D is 44. O, a small o, not a big O, a small o, ends up being 6F. So it's top first, side second. So G would become 67. Everybody okay on that? So you could very easily convert your name. Okay? So we could do Cameron Tillman. And whatever way you do it, I actually saw people do this in the past with Des. Make sure, if you're doing it with a lowercase letter, use the lowercase letters. Okay, I've had people who wrote it down, like for the Des, who wrote their name in lowercase, but they actually encrypted it using the uppercase numbers. And it's like, it does matter, because you'll notice the uppercase K and the lowercase k are two different numbers. Okay, so whatever way you write it down is the way I'll be grading it. All right. So the cipher key, I give that to you. Okay. This is like this. Remember, we talked about symmetric keys before. So this is a symmetric key that I give you. I think yours is a little different. Bless you. Okay. Now let's talk about how to create a round key in here. Okay. Okay. Let me go back. Hold on. Okay. So the cipher key is used to create a round key. Everybody okay so far? We know how to do the whole hex to, or ASCII to hex. That's all we've done so far. Okay. Now we're going to create a round key. So what we do is we take the last column, that 8A, 22, 61, so on and so forth. Take the last column and shift it. Okay? All right? See how the 8A goes down there, and the 22 comes down, the 61 goes down, and the BE goes down. Everybody see that? So it's rotated. Y'all see that? Hopefully. Okay. That's the last column. Okay? Then you take the values and run them through the S box. Remember how it does, I showed the S boxes and they were kind of weird? Well, this is kind of the same thing. They're hard-coded as well. I don't know the reasoning for the way they're hard-coded, but they are. So there's the S box. So then you take that 22, no, the one you just made, because you just made that column. Remember? We shifted it. So you ran it through the S box. All right, so 22 becomes 93. See that? Then the 93 goes up there. Then we get 61 becomes EF.
I have a question.
Yes.
So on the hex diagram, you read from the
Top.
column.
Yes. Let's go back to that real quick. I'm going to make sure everybody get this. You read top. So for instance, G as in dog, you take the small g, ends up being 6, 7.
So you read from that top and then that.
Right. Yes.
Whereas on the other one.
Yes. It's the opposite.
Okay.
Okay? So 61, let's go to the second one. Come on. Yeah. But the cool thing is it does tell you here, first hex number, second hex number. It does say it on the charts. This one's a little easier to understand. Okay? If you're on the hex chart, you go from the top first. So it's basically the column and then the row. Okay, so we got EF, I think was the second one. Yep, EF. All right. And I give you these charts in the assignment, so you... Wait, no, I don't give you this one, do I? I can't remember if I do or not. Let me look. Now you got to make me wondering. Do I give you that S box? But if not, it's in the slides, so you can get it. Yeah, I do. I give it to you. It's right there. Okay? Yep, there's the hex. I thought I gave it to you. Just wasn't totally sure. Okay, so then we got AE, and then the last one is 7E. So that last column becomes that right there, okay? Then you XOR it. Now let's talk about XORing for a second. So remember, we took the last column and converted it to this 93 EF, AE, and 7E. Then we take the first column and that one we just made. So you all know where that 93 came from? The 93 was the result of this. Okay? Where'd that come? Where'd this 22 come from? It was that one column where we brought the top to the bottom and shifted everything else one. Okay. So that's where we got the 93 from. That 37 was the actual first column in there. I can't go back outside of the key 1,000 times. So then we need to XOR them together. It's very simple, but the first time you see, you might be like, huh? Now I'm going to show you two different ways to do it. First way is you can convert it to binary, and I do give you the binary chart on the homework as well. Okay? So if we take 37, with XOR, it's one or the other, but not both. So there's 0 and 1 or the other, but not both. We end up with a 1. 0 and 0 is a 0. 1 and 0 gives us a 1. 1 and 1 gives us a 0. 0. 1. 0. 0. All right, let's see if we're correct. Okay, very simple to do. And I'm going to show you another way to do it, which I did not put on the last year's recording. But since I'm going to let you do this test at home, you can put in 37. Well, I'm sorry, we got to go to hex first. 37 XOR 93. That'll give us A4. Okay. Now, if you look at this value here, 1010 is actually A up here, and 0100 is actually 4 right there. So you can check the answer with the calculator.
You can also switch it to binary.
Yeah, that's true. You can. You can actually say A4 in binary is 10100100.
Oh, wow.
So
Magic.
you still need to know how to do it, because when you get to the matrix multiplication, you can't just do that. There's no matrix multiplication button. Okay? But for the XORing, check your work this way. Okay? Yeah, I didn't put that on last year's recording, so. All right. So everybody okay on how we got that first part? Okay. So we took the 37 and the 93 and get our results. Then we XOR that again with the 1. Okay? And the answer will be 101000101. Everybody agree with that?
Okay, so where did you get the 0, 1?
We got it from right here. So we took the 37 and the 93, we XORed them together. Then we XORed it with the 0, 1. And that result's going to go right in here.
But where did the 1 go?
Oh, that's the Archon. I give you that.
Oh, okay.
Yeah, that's Archon. You have to XOR it with that. Yeah, good question. Yeah, we give you that. Okay? Now, so that result becomes right there, which is a 5. Now, you'll notice on all these other ones, 89 XORed with EF, you don't have to XOR with 00. Because any number XOR with 00 is the number. Okay? So, when you get to these other 3, just don't worry about XORing anymore, and just do the first 2, and then you're good. Are we okay with that? Make sense? Oh, all right. So let's continue. I don't know if I give you all the rest of them. There it is. 66, 91, and then 12. Okay? If you want to verify that's actually correct, again, we can use Mr. Wonderful Calculator here. And make sure you change it to hex or you can have a big problem. Let's do 6C XORed with 7E gives us 12. Yay! Everybody see it? Actually works. Now, if you want to verify that, so if we're going to XOR that with 0, 0, still get 12.
Oh, but you only put 0 in there.
Because it wouldn't let me do 2 zeros. Calculator's smarter than I am. Now, it's kind of funny because way back when I used to teach networking a lot, I always wondered, because whenever there's a service pack for Windows, you always notice they change everything. It's like calculator you can just change. What they had fixed was, I noticed this one year. You notice how let me find it here. Well, actually, you can't click these letters in decimal. See that? They used to actually be grayed out, but now they're not grayed out anymore. But now you can actually use letters, whereas in decimal you can't use the letters. That was one of the fixes they made. It was pretty weird. But I found that. Yep, I found that. Okay, let's continue on. Everybody okay on this step? Okay, so now what we did with that was, remember we took that 37, then we took this row that we shifted, and then we made this row. Okay? All right. So now we're going to take the second column, bring that down, along with that one we just made. We're going to XOR those two together. So the 4A XORed with A5. And we go straight across. You do not use the archon for this one. You only do the archon for the first column. You don't do it anymore.
And you don't shift anymore.
Right, you don't shift anymore. Okay? Just for the first one. Then that goes back up. That goes back up. See, isn't this special? Now how long it took Raymond to make that part? It sucked. It was... Okay, so we have the second. Now we bring down the third column, XOR with the second column to get the results. So then the third goes back up, second goes back up, third comes over. Then we bring down the fourth column, XOR with the third column, creates the new fourth column. Those two go back up, and the fourth column goes back up. Okay?
Intimately familiar with XOR.
Okay, everybody okay with XORing? Again, you can do it with a calculator. I just showed you how, but you can, you can actually even use the calculator for multiplication a little bit, but we'll get there in a second. So no questions so far. Everybody okay with this? Maybe? Somewhat? There's only, I think there's 110 blocks you have to do.
Only 100.
Only 10. And actually, let me show you something here while we're there. Is this it? And that's not it. That's not it. Let me go to the practice one, which I know all of you are going to walk through. See this first state, this 43, 6F, so on and so forth? That's actually used down here. So when I say same as above, just copy what you had above. And you notice when you create state 1 over here on the right, that actually becomes this state down here. So you basically copying one down to the other. When you get state 2, that gets copied to there. When you get state 3, that gets copied to there. When you get state 4, that gets copied to there. The round key comes from the top and you get the results. So when I did it, there's only, I think, 110 blocks you actually have to calculate. For instance, you calculate state 4 here. It's the same numbers here. So if you miss it in both places, I don't take off double. See what I mean? So if you screwed up here, yeah, you can miss 16 points. But it's not going to be 16 here and 16 here. So really, you can miss 16 in state 4 and 16 on the ciphertext, but you're not going to miss these other states again. Okay? Make sense?
I was going to say if you miss the 16 in state 4.
Yeah, if you miss state 4, the ciphertext is wrong anyway. But I'm not going to also take off for the second copy of state 4 and the second copy of the round key. So you're, okay? So again, you can ask for not help, but ask me to check your work, and I'll tell you, hey, you're good up to such and such point. Okay? All right, so let's continue on. We left off. Must be an emergency. Who do I know in Dallas, Texas? I don't want to talk to you, whoever you are. All right. Okay, let's continue on. Okay. So we got that part done. Hit the wrong button, sorry. Okay. So we got that part done. Yay! Okay, that becomes our round key. Now that state, that's the first part where we took our name and converted it. I just brought it down. I just don't feel like going back 27 slides to show it to you, but that is the first part. Okay? And actually, if you want to verify, that's that first part. So right here, it's the state. And if you look at this, you see we actually took this encrypted, computerized 1357 and made this block out of it. And that actually becomes this one right here. So that's the one we're working with now. Okay, we just got done doing this whole round key section. Okay? So now we're working on that one. Okay, so let's go back down. All right. So we have our basically our state, our cipher key becomes a new state. We XOR them across. So 85 XOR with 37 gives us B2, so on and so forth. Easy enough there, just straight across, nothing different. So 16 XOR with 4A gives us 5C. So what ones would do B8, the bottom right hand corner?
06.
06 and BE. Okay, easy enough. Okay, so those are pretty simple there. Okay. Now, SubBytes. You take B2. Now let's find B. B's right here. B's right there. And 2 is right there. I know it's hard to see on this slide, but BE is actually 37. I'm sorry, B2 is 37.
Hard to see?
Is it?
Hard.
So
Hard to see, right.
B2 gives us 37. So those are straight across as well. All right. So far, so good? Nothing difficult yet. We're getting to the difficult part. Okay. Now we get to the shift rows. So remember that 37 we just made here? Now we're using that again. So that's another one of the things that's copied down. Okay. So this row, no shift. This row gets shifted by 1. Watch what happens. It's magic. Ooh, so the 22 that was at the front got brought to the back. This one gets shifted by 2. Isn't that special? Can you guess how much did we do the next one by? 3. You guys are amazing. You just got that. So again, it's nothing difficult. That's what's cool about this algorithm. There's really nothing difficult. It's just basic stuff.
Who came up with this?
The Rich and Dale, those dudes. There was actually a math competition to create this, which was kind of cool. Had to be open source, had to be based on sound mathematics, and they won the competition.
Who did
So.
you say?
Ringdale, R-I-N-G-D-E-A-L,
Virgindale.
Ridge, something close to it. Something from the first slice.
Oh, okay.
Okay. Now, here is where we get a little more difficult. Mixed columns. Here's the part where you're going to have a hard time. Okay? And this is the part where the homework, the test question will be based off of. Obviously, it's based off the toughest question. You know that. Always is. So what we need to do is we need to multiply that column by that row. Okay? And that gives us one value. So, let me show you how this works. Okay? So then you go the second row and the third row. And actually, this is where it's a very good point for me to show you this.
Multiply the first column
Okay,
by each
so if you take this first column, A, B, C, D, multiply it times 1, 2, 3, 4. See how I'm doing it right here? So A times 1. So this A times the 1, the B times the 2, so on and so forth, right here. And when you XOR each one together, all that combined gives you just AA. Okay? Because this is the one part the slide's kind of iffy on. You don't know which column does what. So basically, we take this first column and this top row just to get the A, or the AA. Then we take this first column and the second row to get BB. This first column and the third row to get CC. First column and fourth row to get DD. Okay? Then we take second column, first row to get EE. Second column, second row to get FF, so on and so forth. And I have them all in here. All the way down to, where every block gets where it comes from.
So
Okay.
on that first one, it's A times 1.
Well, it's whatever's in position A. That's actually a good point. Someone last time says, you said just multiply A times 1. No. It's whatever was in block A times whatever is in position block 1. So when I go back to the slides here, so 37 times 02 becomes, that's part of that. So 37 times 2, 49 times 3, 3F times 1, and 6C times 1 gives me the top left position over here. Okay? Let's go look at that again. So this would be the 37 right here. This was 37, and this was 2. So 37 times 2 That's the part of it. Then it's whatever's in the second position here. So whatever's in B times whatever's in 5. If you look at that, B would be 49, 5 would be 0, 1. No, that one, 3. Which one is it? It's 3. Yeah, this guy. No, hell, wait. No, 2. It's 2. It's this one. Now you're confusing me.
Well, it's 2 on this one, it's 3 on the other one.
Okay. Oh, it is 3. Okay. So whatever's in position B times whatever's in position 2. So it ends up being 49 and 3.
Okay, so 30 times 2.
37 times 2.
2 would be-
XORed with 49 times 3. XORed with 3F times 1. XORed with 6C times 1. All that combined becomes the top left block of the new area. Okay?
So how do you multiply 37 times 2?
Actually, it's just XOR. Well, I mean, no, it's XOR together. But okay, I'm going to show you that now. We're getting to that part right now.
I'm getting ahead of me.
All right, here we go. So we got to do 37 and 2. So you do the same thing for the second row. You can look at my other sheet because it'll tell you exactly which ones to use to fill in which blocks, because this doesn't explain it so well. The same with the third one, and the fourth one. All right, so you need to know how to do this. So we take that 37, okay? Okay, times 2. So it's 37 times 2, 49 times 3, 3F times 1, and 6C times 1. You remember that? All that was to calculate the top left block. Remember that? Mm-hmm. So how do we do 37 times 2? Here we go. Convert 37 to binary. Okay. You know, we're going to try this here in a second. So 37 and a 2. Okay. And you need to know this whole thing at the top now for this next part. Okay, so 37 is that. This is some very basic algebra. Think of taking 37 in binary and sticking it underneath that math equation at the top. So 37 has 0x7s. You all agree with that? 0x6s. It has a 1 here. Because remember, it's 0, 0, 1, 1. So it has an x to the 5th and x to the 4th. Has no x to the 3rds, but it has x2, x, and 1. So it's x to the 5th plus x to the 4th plus x squared plus x plus 1. Everybody see that's 37. Y'all see that? Do the same thing with 2. We end up with x. That's it. Y'all see how that's x? Remember, we take 2, which is 0, 0, 0, 0, 0, 0, 1, 0. So it's 0, 0, 0, 0, 0, 0, 1, 0. So if I go next, that's what we get, just x. So far, so good? Okay. Now, multiply them together. Okay. So it's x to the 5th plus x to the 4th plus x squared plus x plus 1. That's 37 multiplied times x. And the way this works is so x to the 5th times x gives us x to the 7th. X, 6, correct, 6. Okay, sorry. X to the 4th times x gives us x to the 5th. X squared gives us x to the 3rd. X times x is x squared. X times 1 is x. So 37 times 2 gives us that. Then we convert that back to our number. Now here's the part I want to try. I don't know if this will work. I did not test this. 37 times 2. I'll be darned. Actually, you can do it in here.
I think you can XOR with the next one.
Nice. Then you can XOR with the next value. So you can check all this with a calculator. Maybe. We're going to get to a part that might not work. We're going to test it here in a second.
Okay, that doesn't work. I already know.
Okay, so this ain't going to work for all of it.
No.
Okay. So far so good on 37 times 2, and you end up with 6e. All right, so then you do 49 and 3, and you get, now let's look at this one for a second. So 49 is x to the 6th, x to the 3rd, and 1. 3 is x and 1. So here, if we go x to the 6th times x, we get x to the 7th, x to the 4th, and x, which we have here, plus x to the, where are we at? Then we got a 1 now. So 1 times x to the 6th gives us x to the 6th. 1 times x third gives us x to the 3rd. 1 times 1 gives us 1. Then you add them together, and you can put them all in the right order, and you end up with dB. So far, so good. So it's a lot of steps, but there's nothing difficult. They're very tedious steps. What I recommend you do is get all the way up to just before this step. Just before you do the matrix multiplication. Ask me to check your work. Because if you do all the way through this section and find out you were wrong at the very top, you're going to kill yourself.
Angry mad face.
So take your homework assignment. Okay. And get all the way through state 3. Get state 3 done. Then have me check it. And if you're good at state 3, at least then you know, hey, I'm on the right track. But if you screwed up on state 1 or state 2 and something, then you did all this matrix stuff, then you'd be like, crap. And it is important to write all this out so you know this times this is this, because if you try to find your errors later, it makes it, it's kind of important. So write it all out on a piece of paper or something and keep it till you know you got it right. Okay? All right, let's continue on. So far, so good. So we're seeing how all that works. So 3f and 1. This one's pretty tough. What is 3f times 1?
3f.
Damn, you're good. Any number times 1 is itself, okay? If you haven't guessed that part by now, it is. Okay. So there's actually quite a few 1s on that chart if you look at it. Okay? So 6c times 1 is 1 as well. Then you XOR all those together. And so you did all that times all that. And we got, okay, that was the number 6e dB, those ones we just did. You can get an E6. All that goes in there. All that work for one block. Okay. This is where computers become into play, because if you had to do this all by hand, that would really suck. But if you were a computer to do this for you, like the spreadsheet that Roy actually made for me that I had to fix. But now that it's fixed, it actually works perfectly. So I can put whatever value in it, does all the math for me. So, that's the whole, I mean, if you want to write a program to do this, great. I'm not going to require you to. I wrote a program all the way up to the Gloyes field, and that's as far as I got. I just never finished it, which is the next part we're going to talk about. So, all right. And see, one click of a mouse and it filled in all the rest of those blocks. Isn't that nice? But that's why I made that other sheet for you guys, because you'd be like, huh? What goes times what? Give me what? So now you know. And they have been verified. My sheet is correct. Because when I first made the sheet, I actually had them sideways. But they're right now.
You mispronounced it wrong.
All right. So let's talk about some possible outcomes. There's something called the Gloyes field, which you'll need.
No.
Okay, so if we took E7, converted it to binary, becomes x to the 7th, x to the 6th, x to the 5th, x squared, x and 1. Okay? If you multiply that times 3, okay, you end up with x to the 8th plus x to the 7th plus x to the 6th plus x to the 3, x squared, and x, plus x to the 7th. See where I'm going with this? See how all that works? So you end up with that plus that times 1 gives you that. Now what you do with this is you cross out like values. Okay? So you're going to cross out the 2x to the 7th, 2x to the 6th. There's a reason why. I'm not a math teacher. I don't know why. You just do it. Okay? It's one of those things. You just do it. It's like you vote Republican and then you just do it. Okay, so let's get.
We know how you voted.
Remember, no for all judges, and Republican then you go. Okay. So you take these values But remember that very first chart when I had that number of the x to the 7 to x to the 6 at the very top of the screen? Remember that? Okay, let's go back a few. You got to remember, I know, I'm going to have to hit it 50 times to get there.
You need two screens.
I know. Okay, remember that? Right there at the top? Remember we put our stuff underneath it? You notice how it starts at x to the 7th? So how can you put x to the 8th in that? You can't, because this is 8 bits. You can't have a 9th bit. It's too much. So that's where this comes in. When you have an x to the 8th, it's too big. So when we multiply all these out, we cancel them all out, we end up with an x to the 8th plus x to the 5th plus x to the 3rd plus 1. We can't put x to the 8th on that other chart.
So it wouldn't be 2x7, x to the 7th.
No.
So you just can't.
So what we do is we XOR it with the Glois field. That's a number. It's just, if you need it on the exam, I will give it to you so you don't have to memorize it. Okay? Well, I mean, hell, you do it at home anyway. You can always look it up. So, since this number right here is too big, you XOR it with this Glois field. And obviously, if we have two ones at the beginning, what happens to the 8th bit? Or the x to the 8th? Becomes a 0. So if we XOR those together, we get 32. Now here's the thing I want to try. I don't think this will work. So if we go E7 times 0.3, it's not 32.
Now, is what you would have to do with that is you would have to XOR it by whatever binary value you had right there.
Yeah, you have to convert this binary to a hex value. Actually, you could.
Yeah, you convert it to a decimal.
We could convert it to binary, then XOR it with 1, 7, 6, 4, 3, 0, 1, 1. Convert this back to decimal.
Convert to X.
Actually, to hex. No, it's still off. Still off.
No,
I might have missed a number in mine.
I think that's right. 22E. No, it should be something.
Should be 32. Well, either way, it doesn't work with the calculator.
It does, just very roundabout.
Yeah, it's not straightforward like the rest of them were. So when you get something that has an x to the 8th in it, in other words, anything where you're multiplying times 3. So when that mixed column value is a 3, just remember that, hey, I might have an issue with this one. So at that point, check. And if you have something in the leftmost column here and a 3, then you need to verify your answer. Everybody okay with that? So, what?
What
Question?
happens if you just put an E7 times 3?
Well, I think we just did that.
Oh, did we? Okay.
I think. Let's try it again, make sure. Okay. E7 times 3. Okay? It's not 32. So anytime you have something when converted to binary, we have something in the x to the 7th position and a 3 down here. So what that means is, let's go back a couple dozen. It really only matters for this position, this position, this position, and this position. So it's really only when you're working with those 4 positions. But you got to watch. So whatever these numbers are, when you convert these to binary, make sure the leftmost value, if it's a 1, and you're working with these 3s, then your possibility you need the Glois field. Didn't do it by hand. Okay? Or else just do them all by hand. It's easier.
So why, you said you don't know why they X out the X to 7?
There's a reason for it. I'm not a math major. You know, I aced algebra 400 years ago. I just don't remember. There's words for all this, and I don't know what it's called. There is a name for that. I was hoping our math guy was going to be here to tell me the name for it, but it's combine like values or something they call it. I don't know what the hell it's called.
Okay.
So I think we should have Cameron figure that out for tomorrow. No, he's like, no. But whenever you're working with the glorious field, you just cross out the common values. Actually, whenever you work with any of it, you cross out the like values. Because, you know, you're going to have duplicates other than with the glorious field. Whenever you multiply, you know, even if you're using the 3, multiply times the number that doesn't have a 1 in the leftmost column, you could still end up with duplicate values. Just cross them out. Okay? Anytime you do multiplication like this, and you end up with duplicate values, just cross them out.
Okay.
You just do it. You just do it. It's like you drive on the left side of the road. No, right side. Left side in England.
We need to add them, but.
Okay. All right. So that was 32. All right. Now the final state, we just take these blocks and end up with our ciphertext. That was after mixed columns. That was after the matrix multiplication. And round key comes down for the top. Then you XOR those two together and you get your ciphertext. So it's actually very simple. If you think about this, it's kind of easier than RSA and DES even. Because none of the steps are difficult. There's just 110 of them. And some of them, one step takes 8 steps to get one step. Okay? Everybody understand? See how that works? That's all there is to it. So, get to state 3, then ask for me to check your work. Don't ask Cameron, he doesn't have the answer key.
I have the answer key.
Right.
Go back to that,
I made the answer.
the next column slide.
Okay, let's go back here to that.
Yeah, so you take 37 times the 2, then 49 times the 3, 3f times the...
Actually, 37 times the 2, XOR that result with 49 times 3. XOR that with 3f times 1. And XOR that with 6c times 1. Because if you notice, okay, so there's 37 times the 2 becomes 6e. 49 times the 3 becomes db. 37 times 1, I'm sorry, 3f times 1 gives us 3f, and 6c times 1 gives us 6c. So after you get those 4, then you XOR them all together.
And then you use that same column for the second row in the next...
Let's make sure. That's why I made this darn thing here. So then you use the same column, but with the second row to get b. So you're going to be using the same column, but this time we're going to be using, so it's going to be 37 times 1, XORed with 49 times 2, XORed with 3f times 3, XORed with 6c times 1. All that is going to give us this dd. Okay, and I want to bring calculator up again. I want to verify that top one's correct. So since we have those numbers up there, we're going to go 6e XOR db XOR 3f XOR 6c, and what should we get? E6. You get E6. So it does work. Okay? It's just a lot of stinking math. Okay? None of it's hard math. But there's just a bunch of it. Okay?
Intimately familiar with XOR.
And the good thing is, once you're done with this, you should know how it all works. Okay, just make sure anytime you got a 3 and a number with a high left bit, you could possibly have an x to the 8th. If you have the x to the 8th, like right here, then you XOR it with a glorious field. Then you take, this is the result of E7 times 3 is x to the 8th plus x to the 5th plus x to the 3rd plus 1. Since we have an x to the 8th, now we XOR it with this glory field of x to the 8th plus x to the 4th, 3rd, x and 1. XOR those two together, and you end up, they're down here, end up with 32. Okay? Simple, isn't it?
Pretty much.
Okay. Now, last year's recording is up there. Feel free to watch it. If you go up on YouTube or WordPress, you can even see the year before that and the year before that. I never showed it with a calculator, though, because when they made them take it in the class, they couldn't use a calculator. So I figure this way you can all check your work, and maybe you won't have some of the stupid errors that, I mean, it's just math errors. Okay? Everybody good?
So do you have the assignment up there now?
Assignment's up there. Okay, it's up there. With the practice one, has all the answers in it. So what you could do is take the assignment, walk through the practice one. Okay? I'll show you what I'm talking about. So the assignment is, that's not it. That's not it. Where's the assignment? Okay, that's not it either. Okay, let me get out of the slides. Let me get out of the slides. Okay, we're done with the slides. So they're all up there, but here's the worksheet. Okay? So take this blank worksheet, walk through this practice assignment. It's all done for you, but do it with the words computerized 1357, but do it on the blank worksheet. That way you can compare your work, make sure you're getting the right answers. Okay? Then once you're sure you got it where it actually gave you the right answers and all this stuff worked out, then you go ahead and do it with your name. But when you get to a state 3, right here, give it to me. Now, I did notice a couple people last semester, so I give you this as a Word document. Okay, a couple people opened it in Open Office, and it comes in very weird. And it's very, very hard for me to grade because like all the boxes are joined together. It was weird. You guys actually have access to Office 365 now through your Rose State email address. So you can actually install Word, Excel, PowerPoint, all for free at home. If you want to know how to do that, talk to Cameron. No. Talk to Arlene. Arlene has a link she will send you. It's totally free. What happens is you go to this link, then you download it, and then you install it. So you can actually have Office 13 for free.
Okay, just to verify, you said Arlene, but you looked at me, so.
Oh, Arlene. Marlene, go talk to Arlene.
Yeah, okay.
Go talk to Arlene, and she'll send you a link. It's funny. It works fine for students. It just doesn't work for faculty. And you can even install it on a Mac and everything. They even have a Mac version up there. It's like, wow. It's just not fair. So, well, I mean, I get it free anyway, but it'd be nice if I could have tried that. See, I get the Mac version of Office, which is like 2011. But if you install the one from your student account, you actually get the newer version, Office 365. So if you have an issue opening in Open Office, please get with me if you can't figure out how to get that one to work, because these end up coming all joined together, and I can't figure what the heck you're doing, and then it's tough.
You should just upload it as a Word document and a PDF. Just say,
No, it's too much work.
I'm not too
No.
much work, sorry.
Reason is, originally I did it as a PDF, but then people had a hard time filling in the PDF. So I uploaded it as a Word document, and now they're,
Just send them to you from our Droid devices, right?
yeah, that's right. Yeah. But yeah, once you get, I mean, I'll even check it before then, but it's pretty straightforward to get all the way to state 3. Especially now that you know how to do the calculator. Okay. Once you get to state 3, I'll verify that. I mean, you can finish the whole thing if you want. Okay. And you can do it all in Excel. Roy wrote the entire thing in Excel. I fixed it. Now it actually works.
If it works just fine,
Yeah, I was making this assignment for you guys, and I checked it with Roy's. I'm like, my worksheet has the wrong answers in it. I said, no, my answers are correct. Roy's were wrong. All right, any questions? Everybody happy? I know you're not happy, but yeah, you're okay. Now let's talk about the test just for a second. This really pertains only to fall 2014, unless I tell you differently. But the test will be next week, so no class on Veterans Day. But the test is next week. I will put the study guide up there before then. I'm not going to have AES on the test, but it'll be on the final test. So I was thinking about putting it on this test, but the assignment's not due for 2 weeks. Is that right?
Right.
So,
Oh, yeah, no, we don't
So I'm not going to put it on there. That just means you got to do like an extra knapsack and RSA and all that on there. All that fun stuff. But it doesn't mean forget this. Okay? So, test will be up there next week. I already had a study guide made. I just need to verify the questions. All righty, let me stop this.